and how he coded the application. He doesn't know what was going on inside because the code was not visible. Okay, so at this time he needs to give some updates. He needs to change some options, or he needs to add some options in the program. So for that we can use a hooking. Okay, basically hooking will change the execution flow of a program. And yeah, let's I will give a small example. Okay, so you are playing some game, and your health is important there. There was a fighting game, and so your health will be, if the health will be 100, you can fight more. But when the health will be reduced to less than 10, you have a lesser time to fight, right? So what we can do, we can hook the game, and we can change the execution flow. So whenever you hit by a target, whenever you hit by some gun or sniper or something, still you will be having 100% health. Okay, so you hit multiple times, like even 100,000 times, so still you will be having a full percentage of health to fight against your target. Okay, so what we did, we just changed, we just given small modification in a program. It's called as a hooking. We just modified the execution flow of the program, and we just uh, we just modified the health to 100. Okay, so whenever we did some kind of hooking in a gaming applications to change the health to make the consistent health like 100 percentage, you can you can continuously play the game. Okay, so this is called as the game hacking or something. Okay, most of them. So by the method of hooking, you can easily achieve that. Okay, the same way in cybersecurity, the defense evasion tactics, the defense evasion programs, it will be doing some API level hooking to hide from antivirus softwares or EDRs programs. Okay, so let me give a small example of how the hooking will be works in the real time. Um, so I have a Bitdefender antivirus program in my machine, so you can see here. And let me go for a task post. So here you can see the application taskforce.exe, and here you can see the handles, DLLs, threads has been loaded. So if you see this DLL, DDHKM64.dll, Bitdefender hooking DLL, so it was involved in the process, right? It was involved in the taskhost.exe process. Why the Bitdefender involving in taskhost.exe? What Bitdefender is doing here? Okay, so let me give a brief explanation. Okay, so let's take an example. I was developing a program, malicious code. So that code will be going to inject a malicious shell code into the taskhost.exe. Okay, so whenever we tries to inject our malicious code into the taskforce.exe. So what we will be doing, we will be calling some kind of API functions, right? Like virtual lock of, write process memory of, create remote thread of. Okay. So EDRs will be monitoring these API functions, and it will be stopping us, right? It will be stopping us, right? So in the backend, EDR monitoring the process, right? EDR monitoring the process. How EDR monitoring the process? How EDR knows uh, our malicious program is going to inject something into the taskforce.exe? How EDR knows? How EDR understand what was going in the background of the process? Okay, so the hooking is coming into play. Okay, so the antivirus software hooked some DLLs into the application taskhost.exe, and it was completely monitoring the process. Okay, so now the EDR know what was going inside the process, what was the IP communication going on, what is the DLLs calling, what is the API functions calls are going on, what was the syscalls going on. Everything EDR come to know the entire process, the backbone of entire process. Okay, so by the hooking technique, the EDR can completely monitor the process, including the APIs, IP communications, contents, code, etc. Okay, so now I already said, so EDR will be one of a powerful tool. It will be it has a capability to do anything inside Windows. It can hook any kind of process. Okay, so in our example, we just seen the task source.txt that was hooked by the Bitdefender hooking DLL process. Okay, so whenever the Windows boots up, the Bitdefender loads a DLL file by calling load library of DLL and hook the DLL inside the taskforce.txt. Okay, by this, so whatever the application was doing, the EDR comes to know, the EDR or antivirus software comes to know what was happening inside the process. Okay, so now I hope you have a clear understanding about the hooking. So what was hooking and how the EDRs and antivirus software will hook. Okay, let's take an example of real world how the malware is going to be react and how the EDRs will be reacting. Let me give you a very brief explanation how it will be happening. Okay, in the superb example, with the super example. Okay, so let's take an example of our day-to-day activities in the home. Okay, not a home. Let's take an example of a restaurant. So the restaurant has a kitchen, right? So inside the kitchen, everything has been performed, like, right? Uh, the cooking, the cleaning, managing, everything, right? So the kitchen. Okay, so the next part of the kitchen will be the head staff. Okay, one of the head chefs is commanding what needs to be done. Head chef, right? The head chef. Who will be coming? And next part will be the waiter. Okay, he will be so we are the customers, and we'll be ordering to the waiter, right? I need a pizza with more cheese or more chicken. The chicken needs some tomatoes, onion, or whatever, right? So we'll be calling the waiter and we'll be ordering, and we are the customers, right? So this is okay. So let's take an example. The kitchen as a kernel in our machine. Okay, we will be calling the kitchen as a kernel, and the head chef as the NTDLL. So we know what is a NTDLL, right? NTDLL dot. This is a DLL file which holds an important API functions which will be used by Windows. Okay, and we can call the waiter as a kernel32.dll. Sorry, I was taking some time. I was drawing in the touchpad. Okay, okay, and the human as a application, okay. You can call the application as a Chrome or task host or whatever, okay. So let's take an example here, okay. So our program telling to the waiter, okay, uh, our program telling to the kernel32.dll, like I want to save a file. I need to save a file. Okay, so you are downloading something from a Chrome, and the file needs to be saved in download folder. So your Chrome calling, I want to save a file. Okay, and it was telling to the kernel.dll. Okay, so it's not a kernel 32. Okay, let me draft that kernel32.dll. And what the next step? So your kernel32.dll calling the head chef, okay, the ntdll, and it was telling the application needs to save some file, okay. So what the head chef will be doing? The head chef will be calling the syscall, okay, direct syscall, and he will be reaching out to the kernel, and the head chef, the ntdll, will be saying to the kernel, like the application needs to save some file. Please allocate some space and help them, okay. So the kitchen directly got the order, and he is cooking the same way. Your application commanding to I want to save a file to kernel32.dll, and your kernel32.dll reaching out to the ntdll, the lower API function. It's a higher level API. The kernel32 dll was a higher level, and it was calling to the lower level API function, the head chef, and that was ntdll.dll, and ntdll.dll giving a syscall to the system call to the kernel, and saying the application needs to save some file. We needs to do some help there, okay. So whenever you need to interact with the hardware, so you are saving the files to the hardware, right? Hard disk, that was a physical parts in our laptop, right? So if you want to interact with the hardware, the operating system, the windows will not have a capabilities to do that, okay. So only the kernel can able to communicate with the hardware as well as the operating system, okay. It was uh, it was uh, it was the it has an it was an intermediator for the hardware as well as the windows operating system, okay. So the kernel only can able to allocate some memory inside the hard disk, okay. The same thing happening here. So the kernel, like the kernel, when the head chef, the ntdll.dll called a syscall, so the kernel goes to the hard drive, and he and it was doing, and it was giving some space to save the file, okay. So only the ntdll.dll can only call the syscall. So the kernel will be only responsible for syscalls, okay. Only it was uh, communicating through the syscall, okay. So the kernel only need a syscall for a communication, so to allocate a space to do anything, okay. So this is the entire overview what will be happen. So once you call anything inside the program, even in notepad you are writing something or anything, okay. So let's take an real-time example. So there is a notepad, and that was an application, and the notepad was calling the write file of API function. It was going to the writer, okay, and it needs to write some file. And what the kernel was doing, so it was calling an API function w write file, okay, write file of, and the waiter going with the head chef, and he's saying this notepad needs to save some file. Okay, the suddenly the API. So this all the higher level APIs. Okay, write file up. Okay, and the NTDLL. So once it reaches to the NTDLL, so the API will be changed to the lower level API NT. Okay, it will be adding NT native write file off. Okay, so nothing gets changed. Only the API functions will be changed. So this all the lower level API functions. So this all the lower level APIs. Okay, so this the higher level write file off, and the NTDLL was a lower level APIs. Okay, and once the lower level API gets called, so the next part will be the syscalls. Okay, the syscall will be calling and it will reaching out to the kernel. Okay, so this is the entire cycle of hooking. Okay, so in our scenario, what our bit defender software did, okay, so our EDR or antivirus software, it will be creating guard. It will be acting as a guard after the kitchen. Okay, so it will be the EDR will be staying here. EDR or AV antivirus software will be staying here, and it will be watching what was happening in the backend. So what APIs was calling, so what was going, and what needs to be saved in the download folder, what needs to be write in the memory or anything. So it will be watching everything. Okay, it will be hooking, and it will be watching each and everything. Okay. So now let's see which functions, which API function EDR hooked. Okay, the EDR hooked the lower level API function NT write off, right? So it hooked the NT write off API functions and watching what was happening in the programs, right? Because it was intermediator for the head chef, and it was intermediator between the kitchen and the head chef. Okay, so in between one API is going to be called the NT write off function that was helping us is called, and this needs to be called. So okay, so the EDR understand each and everything. It was hooked the NT right of API functions, right? So it hooked. So now let's take a real-time example. Let me show you something. Let me open a notepad here. So and I can explain. So what will be done. Let me open what is actually a cooking. Okay, let me open a x64 debug, and let me attach the notepad here, and let me go for a memory map, and let me redirect to the uh, text format, text resource. So yeah, follow in disassembler, and here you can see here you can see the bytes 40 is to 55, and the text section was pointing towards the BCE 1000. Let me open a process hacker, and let me go to the notepad here and load the notepad, and let me search for notepad.exe. So here you can find the same address B75 BCE 1000, right? BCE 1000. Let me expand this. Okay. So here you can see the same memory uh, functions, right? Same bytes, 40 is to 55, then CC8 D Uh, Second. Sorry for the previous one because I already set a breakpoint there. So now you can see the 40 is to 55 and the next byte was 48, 8D, 60, 24, C9, right? So here you can see the 40, 55, yeah. 40, 55, 48, 48, 80, 60. Okay. So what I am going to do, I was setting a breakpoint. Okay, breakpoint and toggle. So now the breakpoint has been set towards this address, and so what we are going to do, we are going to hook this. Okay, so we are going to change the execution flow of that flow of this program. Okay, let me go to the process hacker and let me give a reread. So now you can see the bytes has been changed 40, 55 and CC. So previously it was in the 40, 48, right? So now we can see the CCU has been involved, right? But in before it was a 48. Before I set to the breakpoint, before I setting a breakpoint, it was in the 48. Now it was CC. We just changed execution flow, right? Um, of the program. So now, so if I execute this program, so what the program will do, it will be redirecting to the debugger, right? Because I set a breakpoint there, right? It will be stopping there. Okay, there is a breakpoint, so the program execution will be stopped, and it will be waiting for a next command from a debugger. Okay, so this is called as the hooking. We just changed the execution flow, right? So we just stopped the program from the execution by setting a breakpoint. The address has been changed to CC. The bytes has been changed instead of 48. Here you can find a CC after 40, 55. 48 will be there, but now there is a CC. So now you can see the execution flow has been changed. Now the flow was redirecting to the debugger. So now you can feel how hooking will be, how hooks will be worked. Okay. So this is how the EDRs and antivirus software will be hooking, and it will be monitoring. So what you are doing in the application. Okay. So now let's see how we can bypass the antivirus softwares using the hooking method. Okay, let's go to the draw and take an example. Let me erase this. Give me a sec. Yeah. Now let's take an example about how we need to develop our program here. Okay. So there is a malicious application you are developing. This malicious app, mal app. So mal.exe. Okay. So once you calling any kind of API function like kernel 32 based functions like write file off. So your mal.exe will be going to write a ransom note readme.txt or something. Okay. So your kernel 32.dll will be calling write file of function, right? Write file of function. So once the write file of function get called through the kernel 32.dll, so it will be redirecting towards the heads of ntdll to the function named ntWriteOff. So the important thing we need to monitor, the EDR will be hooked the ntWriteOff functions. Okay. So now whenever your program calls the ntWriteOff functions, EDR knows what was going inside the background. It was completely monitoring what was going inside the background. Okay, so whenever your program calls the your mal.exe calls the nt write-off function, so the EDR coming into play, and it was watching what was going inside the program. Okay, it have a capability to stop terminate your process, even it can do anything. Okay, so now what we can do, we need to bypass this step, right? We need to bypass this step. Instead of calling NT write of the lower level API functions, so what our program needs to do, it needs to the one method we are going to see directly call the syscall API, okay, through the syscall number. For example, the syscall number of NT write of function will be 0x65. This was byte. Okay, let's call this was a syscall number of NT write of function. So our program needs to call the 0x55, and it needs to reach out to the kernel. Instead of calling a function, API function, you needs to call a syscall number. Okay, so by calling the syscall number, you can easily bypass the EDR by EDRs. Okay, so now the EDR doesn't know what was going inside, what was happening inside the program. Okay. So you will be reading a syscall. How you got to know what was the syscall number? Okay, so whenever you started running the application, okay, so application, you need to collect a syscall address. Okay, so the syscall address will be hiding inside the ntdll .dll function. So you need to read a syscall from ntdll functions whenever you started executing the whenever your program was in the execution mode. Okay, so that will be the only method uh, you can easily bypass the uh, EDRs. Okay, so this will be the only step. I hope you have understood explanation about the hooking, so how it will be happening. Okay, so the last time, so instead of calling the API function directly, we can use a syscall number 0x55, and we can, it's an example 0x55, and we can call the kernel. So this is the way you can easily bypass the EDRs without monitoring what you are doing. Okay, so you need to read the syscall number whenever your program was in the runtime, and you need to call the syscall and syscall number, and you can directly reach out to the kernel instead of calling the lower level API function. Okay, so I hope you have enjoyed this video, and we can see you guys in the next video. Bye bye. Hey team, let's discuss about the API hooking, the methods we have. That was the one method we a good method to bypass the reservations, and even the EDRs and antivirus softwares will be also using these APIs to do some task in the machine. Discuss about the. Let me explain API what is a DTOR first. Okay, the so methods we have is one of technique that was introduced by the Microsoft. um, so this is specially designed for intercepting the functions calls, and redirecting it to the custom functions. Okay, so basically, let's say an example of let me give a small example. By the here there is a source function, And
this is specially designed for
let's think about
intercepting the
think about your applications. Your application is going to
calls
save
and
or save a
redirecting to
file
the
by calling
custom
the
functions.
save
Okay.
file of API
So
function.
basically,
So
let's
once
say
the
an
source
example of
function,
let me give
the
a
source
small
function is
by
example.
this
The source function
here
needs to
there is a
save some
source
file. Okay.
function.
So the source
And
function
this is
calling
specially designed
save
for
let's think about
intercepting
intercepting
the
think about your
it
applications. Your
was
executed by the target function. Okay, so once the save file has been once the file has been saved, this was redirected to the source function again. Okay, let's take an example. You are downloading something from Google Chrome or some browser application. So your browser application called save file, that is a source function, and the target function will be it was saved a file. It was executed the save file of and saved a file in the hard disk. So once the file gets saved successfully, it was redirecting again to the source function. Okay, again to the source function. What needs to execute another other. Okay. So this is invocation without interception. So this is something like a function call, right? We are calling a function save file of, and we are doing something, and we are again returning to the to the source function. Okay. So let's take about the detour function. So let's draw in the image. So let's consider a detour. So there is a source function, and we have a target here. So what we are doing, so once the program, once the source function called the target function, so we are saying we are giving some special instructions, special instruction to the target function, like don't execute the target function now. So move to the detour. Okay, just jump to the detour function, and and execute the custom code, execute the code, the detour, and then move to the target function. Okay, so let me give an example. So here we designed a code. So here you can see a simple C++ program here, and I just given implemented a detour function. So here you can see detour transaction begin off. So what we are doing here, okay, so once the program executing the main function, so the next thing will be attach the detour. Okay, so once the function source function gets called, this was redirected to the main function called. Once this was redirected to the detour function. Okay, so now we are telling our program, so what custom code present under the detour function. So what detour was saying, so executes that, okay, executes that, and redirect towards a trampoline function. Okay, so we are temporarily skipping the target functions to execute. Instead of target functions, our program executes the detour of functions. So once the detour functions executed, so our target memory address, okay, our target function memory address will be saved under the trampoline function. And once the detour functions get executes, it's redirected to the trampoline functions. And the trampoline function has our memory address of a target function, and it redirected to the target function and executes that. Okay, so basically in our code what we are doing, so we are just use the detour transaction begin of detour function, and we have attached the function real message and my message box. Okay, so this will be redirected towards the hook function my message box w of. Okay, and it will execute this custom hooked function. Okay, we given the detour attach of the my message box of function. Okay, and we are saved the real message in the trampoline function, and we executing the hooked function, the content of the hook function. And so once the custom hooked function get executes, it redirected towards the original function. Okay, let me explain this code in a brief. Okay, So we will start from the beginning of the code, how the code has been designed. Let me tell you some interesting factor. So now we have the first line. This is the the library thing. So let's skip that. Okay. We are declare a pointer for a real message box W. Okay. This is the real message box. Hello world. This is the normal thing. Okay. This is the one. This needs to be print once we execute the program in our machine. Okay. But you can understand what it will do once we execute the program. Okay. Let's go to the program. So this is the real message w of function pointer, and we just saved the memory address of message box w uh, into the pointer real message box w. Okay. So in this line, we are just uh, taking a copy of a message box W memory address, and we are saving it into the real message box W to use it later. Okay. So this line is called as a trampoline function. Already I said. So this trampoline function has the target function memory address. So once the once the custom detour function has been executed, so after the next step it will be moving towards the trampoline function. So the trampoline function contains the memory address of a target function. So then it will be executing the code, right? So let's move to the program to the next line, and we have few of the custom detour functions. So here you can find the detour functions in the my message box w of sorry, let me have some water. Yep. Uh, so my message box w of function. So in my message box w of functions, so I have written some of the messages, like hooked message w called original text. This message was intercepted by the detour. So we execute the program, and we can understand what will happen here. Okay. So this is the beginning of the detour. So we are just programming. This is like I just said, a special function. We are giving to our program, right? We are redirecting our source function to the detour function. Okay, right? So that's why we have called inside the detour function in the int main of. We just redirected to the detour function. So this is the begin of the detour, and and uh, so this is the message we need to print it. This is the original message. Okay, we need to print it's originally. But let's see how our program is going to execute this one. Okay, let's see. I have a program in here. Let me execute the hoop.exe. And here you can see how my program executed. Okay. So so once I double click on the application, so here you can see the detours example. The message was intercepted by the detours. So this get this get executed, right? So hooked messages. Okay, right? And hook okay, right. Here you can find it just printed a hooked message, and so this will be executed first. Then what it will do? It will execute the detour example. This small console. So once the console get executed, after that the original text will be get printed. Okay, uh, we are just tampering the functions, and we are executing our custom code. We are hiding our custom code, and basically we are hiding our custom code, and we are executing. Okay. So now this is called as the API hooking. We are hooked the message box w API, And instead of executing message box w functions, we are executing the detach my message box w of function, and we are printing the output. Okay, so this will be this is called as the detour function. So you have a question. So why Microsoft introduced a detour function? Okay, let's say an example. I already said some of the programmers who left the organization, and that program needs to get some update. Like that application uh, only have a capability to save a file, but the developer left in between from the company. So now the code was not visible to everyone. So the application. So now there is a different developer working, and he needs to uh, and he needs to update some kind of features like deleting the contents, modifying the contents. So at that time, you can use the detour functions, and you can hook the APIs, and you can execute the program, right? So this is why Microsoft introduced for a benign purpose. Okay, the EDRs and antivirus softwares will be also using this DDoS API functions to remove the threat files from the machines. Okay, so in the cybersecurity threat actor perspective, inside the custom hooked functions, we are hiding our malicious code or hiding our malicious executables inside the custom hooked functions, and we are executing that. Okay, so this is one of the way we can easily hide the antivirus softwares and EDR programs before by using the API hooking. Okay, so instead of calling original message box W of API functions, we implemented the detour, and we have called the my message box W, one of the custom hooked functions, and we executed our code, right? So this method has been implemented in a lot of malwares like keyloggers to monitor the keyboard strokes, spyware, Trojan horse, etc. Sorry, spywares and a few kind of malwares. So this is one of powerful method to bypass the EDR techniques. Okay, this is a simple example. Even you can do a more by extending this program. So you people have a better idea, and so once you complete the course, you can develop a new malware or anything, okay, by using the hooking techniques. So I hope you have enjoyed this video, and you have a clear understanding about what is a detour and how detour API hooking will work. So we can hop off from this video, and we will connect guys in the next video. See you. Bye bye. Sorry. And one more thing. So once we execute the detour things, we need to use the detach, exit the detach. So we have attached the custom hook functions as well as the original message memory address. So once everything has been done, we need to detach the hook before exit. Okay. So thank you for watching this video. We will see you guys in the next video. Bye bye.